1 equals 1 squared, 4 equals 2 squared, 9 equals 3 squared, and finally 16 equals 4 squared. In this video, we will calculate the result of this equation using two methods. The first method involves simulation with 3D modeling, and it's both engaging and visually appealing. I promise you won't want to miss this section. The second method is a mathematical proof using a formula. If you're eager to learn and understand the mathematical aspect, it's worth watching this section as well. Welcome, my friends. In this section, we will explore the sum of squared numbers using 3D modeling. Each square represents the number 1, so 1 equals 1 square, 4 equals 4 squares, and so on, up to 16 squares. Now we need to combine all the squares to illustrate the summation. Next, we duplicate two more of this shape. We then arrange them all together to form a larger structure. To achieve this, we must position the second shape in the appropriate location on top of the first shape. Great! Now we repeat this process for the last one. As you can see, all the layers of the figure fit perfectly except for the last layer. As you can see, the width and length of the shape is n plus 1 and n, respectively. We decide to cut through the middle of the last level. The summation of the squared numbers multiply 3 equals n times n plus 1 times n plus 1/2. So we should simplify the equation. After simplifying, the sum of squared numbers is n times n plus 1 times 2n plus 1 divided by 6. Perfect! This showcases the power of imagination in 3D modeling, and we've achieved our goal. Unlock the secrets of sequences where patterns come to life, numbers dance in harmony, and the thrill of discovery never ends. Hello everyone, in this video we will demonstrate a sequence equation. To begin, we need a starting point, so we've chosen this equation. We've simplified it by omitting 1 power 3 with negative 1 power 3, and similarly for 2 power 3 and negative 2 power 3. Consequently, the right side of the equation simplifies to n power 3. We can say sigma r power 3 minus r minus 1 power 3 equals n power 3. Now, let's simplify the left side of the equation using algebraic identities. We assume you're familiar with these concepts, but if you need a refresher or have forgotten the formulas, please refer to our earlier video. We're breaking down the elements of this sequence equation. We begin to simplify. We've labeled the red rectangle as A and the other box as B. We can see that the value of A is n, so let's substitute A into the main equation. Next, we address B. We've identified this formula from arithmetic progression. If you're unfamiliar with it or want a complete understanding, we recommend watching a preparatory video. Just as with the previous step, we substitute B into its place in the equation. Since we have two identical equations, we need to make sure the right sides of both equations are equal. We begin to simplify. After all the simplifications, here's the result. Great! Thank you for dedicating your time to watch this video. To support us, subscribe our channel. If you like the video, share it with your friends.